Egypt gives significant attention to energy and enhancement of energy efficiency to amplify the economic activities, profitability, and safeguard the environment, in line with a national plan aiming at reduction of greenhouse gas emissions, as well as supporting economic growth and national industry. Egypt has recently developed a comprehensive plan to enhance resources efficiency and minimize greenhouse gas emissions. Among the actions undertaken was when the Ministry of Trade and Industry issued the Ministerial Decree 463, issued year 2020, for enhancement of electric motors efficiency in industrial operations. Accordingly, the United Nations Industrial Development Organization, in cooperation with the Ministry of Trade and Industry, and with funding from the Global Environment Facility, have implemented the project Egyptian Program for Promoting Industrial Motor Efficiency, which facilitates the relevant decree issued by the Ministry of Trade and Industry and supports the Egyptian policies aiming to mitigate greenhouse gas emissions resulting from inefficient motors used in the industrial processes, especially that electric motor systems account for 70% of industrial electricity consumption worldwide, and enhancing their efficiency would save nearly 4% of the electricity consumption in Egypt. The Ministerial Decree 463/2020 includes two segments. The first part tackles the nameplate labeling for all AC motors in Egypt, showing the degree of energy efficiency as per the Energy Efficiency Classification, i.e. code, and in relevance to the declared tables in the Egyptian standard. The decree applies to single-phase and three-phase AC motors with a capacity of 0.12 kilowatts to 1,000 kilowatts, and with the characteristics specified in the decree, provided that the decree would apply to motors with the mentioned specifications within a maximum period of 6 months, starting the issuance date of the ministerial decree. This would ensure that the end user is aware of the motor's efficiency and selects the most appropriate motor to achieve the optimal savings in the end user's facility. The second part of the decree tackles applying the minimum energy performance standards, which would prevent entry of low-efficiency motor, less than IE3 efficiency, into the Egyptian market. The decree applies to three-phase squirrel cage induction motors with a capacity of 0.75 kilowatts to 375 kilowatts, and should be applied to motors with the mentioned specifications within a maximum period of 18 months, starting the issuance date of the ministerial decree. The ministerial decree, enclosing these its two segments, applies its provisions on motors with voltage 50 volts to 1,000 volts and frequency 50-60 Hz, single-speed motors with number of poles 2, 4, 6, 8, and duty cycle S1, and direct online operated motors which are not connected to the equipment or machinery. Apart from that, motors are not subject to the provisions of this decree. Hence, the ministerial decree compels the producers and importers of electric motors to conform to the Egyptian standards, equivalent to that of the international standards for electric motors' energy levels, as well as facilitating the import and manufacturing of motors based on the energy efficiency to eventually develop specific mechanisms to validate their efficiency levels according to the Egyptian standards, or the equivalent accredited certificate emphasizing conformity with the energy efficiency level. Electric motors are used in many manufacturing processes, including compressing and moving materials, as well as ventilation and cooling systems, water pumps, and air compressors. Studies and practical experience show that there are great opportunities for developing energy optimization of electric motor systems, whether in developed or developing countries. Energy-saving opportunities in electric motor systems include several interventions, including optimizing coupling elements, maintaining a balanced voltage source, coordination between motor groups, reducing air pressure in compressed air systems, practicing good rewinding practices, using variable speed drives, proper motor sizing, and using high-efficiency motors. These interventions are evaluated by different measures, such as ease of implementation, cost of implementation, savings resulting from their implementation, in addition to their prevalence in industrial facilities. The International Energy Agency estimates the available savings in electric motor systems in the industrial sector to range between 20 to 30% of the consumed electricity, which could reduce global demand for electric energy by 10%. However, from a realistic perspective, the International Energy Agency proposes a more achievable target for the International Action Plan, which is to improve electric motor systems optimization by 10% to 15%. Having a maintenance and motor replacement management plan could help achieve long-term energy savings in plants, as it ensures motors are replaced in a timely manner and maintained in an efficient manner. Following up the motor's performance and up-to-date management plans include preventative and predictive maintenance procedures, which would ensure motors to operate continuously and avoid malfunctions that could hinder the production cycle. In some cases, it may be better to repair the motor, rewinding it, when it encounters malfunctions, rather than buying a new one. When repairing or rewinding motors, it is important to follow motor rewinding best practices in order to minimize losses resulting from potential low efficiency. The selection of high-efficiency electric motors depends on the motor operating conditions and the investment lifecycle costs. In general, high-efficiency electric motors are economically attractive to replace motors with more than 4,000 operating hours per year. Often, replacing the motor with a more efficient one may have an excellent financial return compared to inexpensive and low-efficiency motors.